Hello, everybody. The next section we're going to talk about is so many different ways to find zeros given polynomials. So there's going to be so many ways to do this. Okay, so what we're going to do first is to talk about how to find zeros through factoring. So we talked about factoring. You guys are factoring pros. Okay, but once we are in factored form, we need to be able to find zeros. Okay, so zeros are the same thing as x-intercepts, roots, or solutions. Okay, they all mean the same thing. Zeros, x-intercepts, roots, and solutions. So if you ever get asked to find any of those, you're finding the same thing. Okay, so once we get into factored form, okay, which this is what factored form is. So let's think about what a factor is. So factors are things that multiply to equal something else. Okay, so they are things that are multiplied together. So x minus a is multiplied to x plus b. Okay, so this is factored form of your polynomial. If I were to distribute all this stuff back out, we'd end up in standard form. So factored form is another way to write your polynomial, which is pretty cool. So let's think about this, you guys. If I have two things that are multiplied together and you get 0, let's think about it. What times what gives me 0? Well, at least one of these has to be 0 because something times 0 gives me 0. Or both of them could be 0 because 0 times 0 is 0. Okay, so this is called the zero product property, which states if you have two things that multiply together and get 0, okay, at least one of them has to be 0, but both could also equal 0. So if a times b equals 0, then either a or b is 0, or both could be 0. Okay, so once we get this thing in factored form, we'll set each of these equal to 0 and solve. So like here, we'd set x minus a equal to 0, and we'd set x plus b equal to 0, and we would solve. Okay, so that's what we're going to be doing. So after we do all those lovely factoring techniques we talked about, so hopefully you remember that nifty chart from the previous Prezi. If not, I will be showing it to you again. After we factor this, we'll be setting each factor equal to 0 and solving. Alright, now, things to watch for when we are solving for the zeros. There's lots of things we talked about that you might forget about, which that's when the demon cats love to prey on you, so watch out for these things. Remember, the total amount of zeros should always equal the degree. So when you add up all the real zeros and all the imaginary zeros, it should equal the degree. Okay, which the way you know the difference between a real zero and an imaginary zero, a real zero does not have an I in it, and an imaginary zero does have an I. So when you add up all the ones without the I's and with the I's, it should equal your degree, which remember the degree is your highest exponent in standard form. Sorry guys, I didn't mean to do that. Alright, another thing, if your factor repeats, you count all of them as zeros, all of them. Okay, so you list them more than one time, and they will be more than 1 0. So like if you get your factors are x minus 1 and x minus 1, they both count. So you'd set each of these equal to 0, and your zeros would be x equals 1 and x equals 1. So this means that there are two real zeros. So even though there's only one solution, solution means how many different answers do you have? Okay, so I only have one solution, okay, but I do have two real zeros. So I have one unique answer, but two of them. So two real zeros. Okay, something else. Okay, if you ever use a difference or sum of cubes, so if you have to factor using those techniques, you have to use the quadratic formula to find the zeros on the trinomial. Okay, so the trinomial term, when I'm talking about trinomial, I'm talking about the factor that contains 3 terms. Okay, so whenever you use a difference or sum of cubes, the factor that has 3 terms, you cannot solve this using slide and divide. It will not work. Okay, so what you have to do is the quadratic formula every single time. Now the binomial term, the a minus c or the a plus c, you can just simply set that equal to 0 and solve. That's pretty simple. Now the trinomial though, the one with 3 terms, you have to use the quadratic formula, unfortunately. Well, not really unfortunately, but you are limited to one technique. You can't slide and divide or quadratic formula. You have to use quadratic formula. So your options are very limited when you use a sum or difference of cubes. Don't forget, you guys, if you see a negative under a square root, that I must pop out to make it positive. Do not forget about that. And lastly, don't forget, if you square root both sides of an equation, a plus or minus must pop up. Do not forget. Okay, so we will be referencing this chart over and over and over because we're going to be trying to factor, so we have to know which technique to use. So, at any point, if you need to use this chart, go back to this part of the Prezi. So we're at, let's see, I don't know what time we're at on the Prezi. Let me see if I can see here. No, it doesn't tell me. Okay, well, it doesn't tell me how far along we are, but you can go back to this part of the Prezi and see what the chart is. I also will show you the chart when we work example problems. So, this is also in your notes from the previous section in the factoring section, so you can also reference that. Okay, let's keep going. Alright, so in class, we did this nifty activity for you guys to find the real or imaginary zeros. So if you weren't in class, okay, this is the activity we did. Da, da, da. Come on, thing, pop up. Pop up, pop up. Well, it's being slow, but this will show you the problems we're going to be working, which I do have them in the example problems that I showed you from earlier. Okay, so, which hopefully eventually will pop up. Come on, thing. Da, da, da. Okay, well, let's see if I can pull it up a different way since it's being slow. Alright, so it's also on my classroom website. If you click on Math 3, go to In-Class Activities, go to Unit 3, and click on Real Roots of Polynomials. Okay, the activity I'm trying to pull up is this one. So for some reason it's being slow and I don't know why. Okay, but basically what we're doing, you guys, for these three problems, we have example 1, 2, and 3 on the activity. These are going to go in your handy dandy notebook, so make sure you guys write these down. If you cannot see it right now, they are on the example videos, so don't fret. If you can't see it now, you can see them on the example problems. Okay, so if you weren't in class to do these problems with us, go ahead and pause the video and watch examples 1, 2, and 3, and you'll be finding all the real and imaginary roots. It's going to be exciting. Okay, you guys, so we have even more examples on finding all real and imaginary zeros. Okay, so the reason why I'm making you guys do 2 more is because not only is it a fun activity, because we love to factor. I mean, factoring is so much fun. But other than that, I have given you 2 problems that require different factoring techniques than example 1, 2, and 3. Okay, so this is going to kind of show you how to approach problems when you have a different factoring technique on how you find the zeros. So go ahead and pause the video and watch example problems 4 and 5. Alright guys, so now we've been dealing with standard form. I've given you problems in standard form. So this is when we list the terms from the highest exponent all the way down to the lowest exponent. Now we'll be dealing with explicitly factored form. So let's talk about factored form. It looks like this. Okay, we have 2 things that are multiplying together. Let's talk about the parts of factored form. So the leading coefficient is that A value right here. It's the very first number you see before your first parenthesis containing an x. So you basically see an x or an equal sign, and whatever the first number is without an x, that is your leading coefficient. The factors, these are the things with a parenthesis, which factors always contain x's. So if you see an x in the problem, okay, it's going to be a factor. Alright, now the zeros. Okay, our zeros, basically, if you set each factor equal to 0, you can get the zeros. Or shortcut, if you guys see, at negative p, it was x minus p, but down here, it's positive p. Same with this. It's x minus q here, but down here, it's positive q. So the shortcut, if you guys see that it's in factored form, if you just change the sign of these, that will be your zeros. Alright, and next, multiplicity. So the multiplicity of a zero is what is the exponent on the 0. Okay, so, or what's the exponent on the factor? Okay, so when x is p, that pertains to the factor x minus p, so the multiplicity of that factor is m, it's the exponent. And the multiplicity when x equals q, that pertains to the factor x minus q, and the exponent is n. So basically multiplicity is what is the exponent on the factor that pertains to the 0 that you're looking at. What are the exponents? And the degree. So, when you are in factored form. The degree, you have to add up all the exponents or all your multiplicities. That's different from standard form, because remember you guys, in standard form, the degree is your highest exponent. Like this one, the highest exponent I see is 3, so it's degree 3. In this one, the highest exponent you see is 3, so it's degree 3. But in factored form, you have to add up all the exponents, so it's a little different. So you guys kind of have to recognize, is it standard form or is it factored form? And then you have to think about, how do I find the degree? Because they are slightly different. Alright, so in example 6, you're going to be working with factored form. So you're going to be finding the leading coefficient, then finding the zeros of the polynomial, then the multiplicity of each zero or the exponents, and then the degree. So go ahead and pause the video and watch example 6 and have a blast, you guys. Okay, so in class we did this nifty activity where you guys found out how the graph behaves at zeros, and it's actually based on the multiplicity. And it's based on if it's an even or an odd multiplicity. So, in factored form, if you have an even exponent, okay, the graph is tangent at the zero, or it will bounce off. Okay, so see how it kind of comes to the zero, it's like boing, and it bounces off? If you see a graph behaving like that, it has even multiplicity. Or if you reverse it, when a zero has even multiplicity, you know the graph is tangent or bounces at the zero. So if you have the equation in factored form, you already know how the graph is going to behave, which is really cool. Or if you have the graph, you already know at that zero what the exponent's going to be. Okay, at that zero, it's going to have an even exponent. So it's pretty cool. Now when you have an odd exponent on your zero, the graph will cross through at the zero. So you guys see how the graph's kind of coming through and bam, it just crosses through and it keeps going. If you see that, it means the graph has odd multiplicity. So on the graph, if it crosses through, it has odd multiplicity. With the equation, if it has an odd multiplicity, you know it crosses through. So it's kind of cool. You can predict the graph before you even graph it, which is really cool. Okay, so in example 7, we're answering the same questions we did as in example 6. The only thing, we have an extra question. Graph behavior at each zero. So you're going to be telling me if the graph is tangent or if it crosses through at the zero without seeing the graph, which is pretty epic in my opinion. So go ahead and pause the video and watch example 7. Alright, you guys, so in example 8, I'm going to give you a graph. I'm going to give you an equation in standard form, and using this information, we can find the zeros and the leading coefficient, and with standard form and this information, we can write it in factored form through synthetic division, which is really cool. So we're going to be combining what we talked about in this polynomial division section as well as with our properties of factored form. Okay, so we're kind of combining everything we talked about in this section and previous sections, which is pretty cool. Okay, so after we find the zeros and the leading coefficient from the graph and from standard form, we're going to use synthetic division to get this thing into factored form. So we're going to make it look like something like this. We're going to turn it into something like what example 7 looks like, which is really cool. Okay, and then after we do that, after we get it into factored form, we're going to talk about this information, which, if you notice, is the same thing we talked about in this problem. Okay, so we're basically going to answer these questions about factored form once we get into factored form, which you guys are pros at that, so that won't even be tricky for you guys. The harder part will be getting it into standard form, but we're going to have a great time doing that, and I know you guys are going to love doing it. And when we do these problems, you guys, when I give you the graph, we're going to assume all the zeros are real because we can only see real zeros on this graph. We cannot spot the imaginary zeros. So in all these kinds of problems, all of our zeros will be real zeros. So go ahead and pause the video and watch example 8, you guys. Okay, so example 9 is basically the same thing as example 8. So if you felt confident about example 8, I recommend that you try example 9 on your own and fast forward to the end and see if you get it right. So go ahead and pause the video and watch example 9. That's a funsy, you guys will have to wait on that one. Alright, you guys, so sometimes you will not have a graph to look at. So I will give you standard form. So if I go back to here, I will give you standard form, but I will not give you the graph. So you will not have the zeros, which means you won't know what to put in the box when you do synthetic division to reduce this down to factored form. But there is a way around it, you guys. So if you have a problem and you try to factor it, factoring is always the fastest way, you guys. So if you see a polynomial, try to factor it first. If factoring fails you and I did not give you a graph, what you have to use is something called the rational zero theorem. So let's talk about that. Rational means something that can be represented as a fraction. So it has to do with fractions, and it has to do with the list of potential zeros. So let's talk about what I mean by that. So we're going to be creating a list of potential zeros for the polynomial, and they'll be in the form p divided by q. So I'm going to give you a list of possible zeros. So they might not be the actual zeros, but these will be the numbers that we put in the boxes when we're solving. So if you think back to when we did all this, okay, we knew the zeros because we saw it on the graph. So we knew these would be the numbers we put in the box. Like I'd put 2 in my box because it's a 0. What we're going to do now, we're going to come up with a list of possible zeros that we'll be putting into the box in synthetic division, and we will find out if it's a 0 if we get 0 as a remainder. If we don't get 0 as a remainder, it will not be a 0, so we have to pick another thing off the list. Okay, now, the form p over q, let's talk about what that means. So p, the p-values, will come from all the factors of our last term in standard form, or our constant term. So we're going to write everything that goes into the last term for our p-values. Our q-values is everything that goes into the first term. And then we're going to take all the p's and all the q's and divide them. And that will be our potential list of zeros, which we will be putting into the box to test in synthetic division. And eventually, we'll be able to write our standard form and factored form, which is pretty cool. Okay, so we take every p and divide them by every single q. And that will give us our list of p and q values. And when we do this, we're going to write all of them to have a plus or a minus value. Okay, so see this plus or minus? Because technically, like, say that your p value is 8 and your q value is 1. So we have 8 over 1. But technically, you guys, okay, you can divide 8 by positive 1 or negative 1. Okay, we're not limited to that. Okay, so all of our factors are positive and negatives. Okay, when we get our p-values, like say that we had negative 32 as a p-value, positive and negative numbers go into negative 32. So that's why we list them with the plus or minus. Okay, same with the q's. Okay, if the number was a positive 2, positive and negative numbers go into 2. Okay, so that's why we list our answers with a plus or minus, which if that doesn't make sense, you guys, it will make sense when we do our next example problem. So all we're going to do in these, you guys, is just practice listing out our list of potential zeros. So we're going to find all the p's, all the q's, and then divide all the p's by all the q's. So we'll be finding the p-values, which are all the factors of the last term, and divide it by the q's, which are all the factors of the first term. And that will be our list of potential zeros, which we'll be putting in our boxes in the next example problem. So go ahead and pause the video and find out how you find the p-values, the q-values, and the p over q values. Alright guys, our last example problems of the unit. So, we are going to be finding all the zeros using the rational zero theorem, which this is the rational zero theorem, you guys, when we found the p's, q's, and the p over q's, which you guys are pros at, so I'm confident you can get that. So, what we're going to do, we're going to find the p's, q's, and p over q's, and like I've been hinting at, now we're going to be finding the zeros, and we're also going to be writing our answer in factored form. So, we're going to kind of do what we did back here in these problems, you guys. Actually, we're doing exactly what we did in these problems, except this time, we won't have a graph to look at. So, you have to use your p over q values to tell you what values you put in the box. And if you get 0 as a remainder, you have found a 0, which means you have also found a factor. So, we'll be on the lookout for those zeros when we solve. Alright guys, now these are a doozy, so these are going to take a while, but they're a lot of fun. Okay, and I know you guys can do it. I know they're long problems, okay, but I'm confident that after we do these two together, we will feel better about it, and I will definitely be able to help you on the funsies. So, do not get discouraged if example 12 and 13 are frustrating at first. Later on, I promise they won't be. Okay, so go ahead and pause the video and watch example 12 and 13. Holy hot dog, you guys. You guys conquered one of the toughest sections in the unit, so I'm proud of you.